Good morning. Am I audible?
Yes, sir. Good morning, sir.
Tananya Balaji. Okay. Two more are yet to join. Others also, please keep your videos on. Yeah. Yes. So we have discussed the basics of all the concepts related to set, right? We saw what is a Venn diagram, right? And we saw what is union, intersection, and then difference of sets as well, based on which I think we solved some problems also, right? No. See, as per your syllabus, complement of a set is the last part, but as I told you, for probability, you need the basics of next exercise as well. So to ensure that the basics are strong, I'll teach you the concepts and do few problems based on it. The complement of a set is a very simple concept. We'll finish it faster. Maybe in the first half an hour, we can do it off. And in the next half an hour, we'll sit and do the next exercise, few problems. Am I clear with that? Right.
Sir.
Okay. So write down the heading as complement of a set. Okay. So what do you mean by a complement of a set? See, suppose I take a universal set like this. If I take a universal set like this, and let's say there is a set inside it, which I name it as A. Okay. Then what will this region be called as? Then what is this region called as?
It's a null set.
This is what is called as complement of set. So you have a universal set. From the universal set, if you remove all the elements that are there in the given set, then that will give you the complement of the set. Okay. So listen to this carefully. Let U be the universal set which consists of all prime numbers. Let's take an example, which consists of all prime numbers, and A be the subset of U which consists of all those prime numbers that are not divisors of 40. So how will you write set A as? So A will be equal to the elements X, where those elements, where are they coming from? They are coming from the universal set. And what is the condition it needs to satisfy? X is not a divisor of 42. Okay. So if you take the universal set, what do you have? You have all the prime numbers. What is there within the set A? Within the set A, you have all those prime numbers which do not divide 42. See, for example, if you start with the prime numbers, what are they going to be? 2, 3, tell me. 2, 3, 5,
5, 7,
11,
11,
13,
13,
17,
17,
19,
22. No, sorry. 23. 29.
30 will work. 31.
Yeah, 31.
32 works. It's an even number. 33 works. 34, 35, 36, 37.
37.
37. 38,
40,
40,
40,
40 doesn't work. No. 41.
41.
So after this, I'm not writing because I told divisors of 42.
40.
The highest divisor of 42 will be itself. Okay. So like this, after this, you still have the set existing. That is going to be the universal set. From that universal set, how am I able, how should I prepare the set A? Set A should consist of what elements?
Set A should only contain the elements which are the divisors of 42.
Which are not divisors of 42. Read the question. A is a subset of U which consists of all those prime numbers that are not divisors of 42. So what are the divisors you can see? 5. 5 is one such number. Then you can think of 11, 13, then 17, 23,
Excuse me,
29.
sir. I didn't understand the statement. A be the subset of U which consists of all those prime numbers that are not divisors of 42. They are telling that the subset A contains all the prime numbers which are not divisors of 42. In that case, A contains the divisors of 42, right? Only subset of A doesn't.
A itself is a subset. A is a subset of U. U is a bigger set. A is a subset of that.
Oh, okay, sir. I got confused.
So 5, 11, 13, 17, 19, 23, 29, 31, 37, 41. All these numbers will be there. Then what numbers will be outside this set? You will have 2, 3.
5, 7, 11.
No. What will be outside A?
Divisors of 42.
Divisors of 42. What are they? 2, 3,
7.
7. That's it. No.
Yes, sir.
Apart from that, you will have the other prime numbers also. You will have the other prime numbers. So this set 2, 3, 7, which is outside the set A, is called as the complement of the set. See, if I have to speak in probability language, right? If I have to speak in the language of probability, let's say there is a possibility, let's say there is an event or an experiment where you are performing a task of tossing 2 coins simultaneously. Then what is going to be the sample space? Head, 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 tail, tail, head, and tail, tail. Am I right? So suppose I give you, find the probability of you getting both to be tails. Then which one will you take?
Tail, tail.
So you will take only A is equal to T comma T. Then what about this head, 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 tail, tail, head?
P of not E.
This is going to be probability of not getting 2 tails. No, this is what is called as the complement set. So from the bigger set, you take out one set, you keep it aside. So whatever is there in the set that you kept aside will be in itself. The elements which are there in the bigger set but not there in the smaller set is what is called as the complement of that set. So complement is basically something not happening. As per the statement, something not happening is what is called as the complement of the set. Okay. Now, having said this, if you look at the definition, you'll understand it better. Suppose I have a universal set and A be the subset of U. Then the complement of set A is a set of all elements of the universal set. So those elements will be a part of the universal set, but they will not be a part of the smaller set A. Those are what are called as complements. So which are not the elements of A. Symbolically, we'll write A complement as those elements X which belong to U, and simultaneously they should not belong to A. So to put it simple, I draw the Venn diagram again. Okay, listen to this carefully. If I draw the Venn diagram again, what does a rectangle always represent? U.
Universal.
Suppose I take a universal set where you have universal set which contains a set of all natural numbers. So within the universal set, what will you write? You'll write 1, 2, 3, 4, so on till infinity. Right. Now I'm defining a set A where set A consists of only odd natural numbers. So what will you put within the circle? You'll put 1, 3, 5, 7, 9, so on, right? This is set A. Then what will be the complement of the set A?
The even numbers.
That's it.
Even numbers.
That's it. The ones which are there in the universal set but not there within the set A are what are called as complement of set, meaning the outer region other than A is what is called as the complement of itself. So this region is basically A complement. So in this region, what will you have? You will have 2, 4, 6, 8, 10, all these numbers distributed around. Am I clear with this?
Yes.
Yes, sir.
So listen to this. Now we will understand the definition better. You have a bigger set which is called as a universal set. A is a subset of the universal set, which is a circle inside the rectangle. Then the complement of set A is all those elements of U which are not the elements of A. So how will you write it? A complement is equal to X such that X belongs to the universal set, but X does not belong to A. So how will you write it in terms of difference? You will write it as A complement is equal to U minus A. So you know how to handle U minus A. We saw it yesterday. Sometimes they call it as negation also. Why they call it as negation is because it is not happening.
Sorry, sir, but can you repeat why they call it as negation?
Because they do not happen. They are not available.
Okay.
You're taking the difference. No, from the bigger set, you're removing the smaller. That's the language used in probability. As I told you, this has a lot of applications there.
Okay, sir.
So if you look at example 20, right? Let U be the set of first 10 natural numbers, A be a set of odd natural numbers, 1, 3, 5, 7, 9. Then what is A complement?
The even numbers in
That is
2, 4, 6, 8.
the even numbers which are there in the universal set, 2, 4, 6, 8, and 10. That's it. That's the answer. Okay. Suppose let U be the universal set of all students of class 11 of co-educational school and A be the set of all girls in class 11. Find A complement. So universal set be the, what are you going to have? Universal set is set of all students of class 11 of a co-educational school. A be the set of all girls in class 11. Then what is the A complement going to be?
the boys in the co-educational school.
The set of all boys who are a part of the school. Right. So here you can make a note of this point. If A is a subset of universal set, then A complement is also a subset of universal set. Why is it so? Because A complement also falls within the rectangle. If A is a subset of universal set, then A complement is also a subset of universal set. Makes sense? Similarly, if you take this example number 20, right, you have A complement as 2, 4, 6, 8, 10. Okay, let me call this as set B. I'm just giving it. So A complement or set B, both the names mean the same. Okay, then what is the complement of this set itself?
A.
It is going to be set A. Because A complement is a set of all even numbers. Then what will be the complement of those set? It will
All
be
odd numbers.
odd numbers. All odd numbers is nothing but the set A itself.
Oh.
So that is how it works. We'll see this under a property, right? Next, 22nd. So there are some properties we are going to discuss. Before we see the properties, right? We'll see these examples. So let U be 1, 2, 3, 4, 5, 6. A is equal to 2, 3. B is equal to 3, 4, 5. Okay. Find A complement and B complement. Balaji, will start with you. So universal set is 1, 2, 3, 4, 5, 6. What is A? A is 2,
2,
3.
3.
What is A complement?
A complement is all the numbers in the universal set except 2, 3. That is 1, 4, 5, 6.
Correct. What is B complement? What is B first of all?
B is 3, 4, 5.
What is B complement?
B complement is 1, 2, 6.
Okay. Anirudh, you tell me. What is A complement intersection B complement? You have
It's 1 and 6.
correct. What is A union B?
Three, sir.
A union, not intersection.
2, 4, 5.
2,
4 and 5. 2, 3, 4 and 5, sir.
So 2, 3, 4, 5.
Correct.
And then you tell me, what is A union B, the whole complement? What is there in universal set but not there in A union B?
Can you repeat what I like?
No, see, A union B, the whole complement is whatever is there in the universal set but not there in A union B.
1, 4.
Correct. 4 is there, no?
1, 6. 1 and 6.
That's it. So if you observe one thing here, A complement intersection B complement is exactly coming out to be the same as A union B, the whole complement. Makes sense.
Yes, sir.
So A complement intersection B complement is exactly the same as A union B, the whole complement. See, don't write it now. As of now, I'll tell you, observe them. The laws, when we discuss the laws, you'll understand it better. So these are all the examples that are considered to frame those laws. Am I clear with this problem? Right. So this one, make a note of all the values. So write down the solution for this. Write the universal set A, B, and all those values. Done?
Yes, sir.
So that is all with this concept. So if you see, this diagram is the one which I drew previously. You have a bigger set, you have a subset A within the universal set. Anything outside that is going to be the complement, right? So based on this, we'll see some of the properties of complements. So first is complement loss, where it says, if you take the union of the set and the complement of the set, you will get the universal set itself. That's obvious, right? So you take the union. Union means you take this value and the bigger set. When you put both of them together, you're going to get the universal set. Whereas if you take the intersection of both, A intersection A complement will be a null set. So this is what is called as complement loss. Okay. Secondly, we have something called as De Morgan's loss. So De Morgan's law states something like this: A union B, the whole complement, is equal to A complement intersection B complement. That is what we proved in the example. A complement intersection B complement is equal to A union B, the whole complement. Right? The reverse is also applicable. If you do A intersection B, the whole complement, then you will get A complement union B complement. Okay, write this first. We'll check with that example if it is working or not. So first write down this one. So write down these 2 points. Done?
Yes.
Done with, okay. Now see, what is the second part saying? A intersection B, the whole complement, will be equal to A complement union B complement. So what is A complement union B complement? You have A complement here, B complement here. What is it going to be? 1, 2, 4,
5,
5,
6.
6. Okay. What is A intersection B? What is A intersection B? 1 minute.
3.
A intersection B is 3. What will A intersection B, the whole complement be? Everything that is there in the universal set, but not there in A intersection B. So what is the answer going to be?
1, 2, 4, 5, 6.
So are they both matching?
Yes.
Yes, sir.
That's what is De Morgan's law. Makes sense?
Yes, sir.
Right? So if you want to copy, just copy it. The other 2 laws we have already discussed. The other 2 properties. Shall I proceed?
Yes, sir.
So see, there is something called as law of double complementation, which is the complement of the complement. This also we saw. A complement's complement is A itself. Similarly, there is law of empty set and universal set. So the complement of a null set is universal set, and the complement of a universal set is null set. Obvious, right? Complement of nothing is everything. Complement of everything is nothing. Right?
Yes.
So the basics are built, right? We'll go to exercise 1.5. As I told you, there are only 7 problems. It should not take more than 10 minutes for us to complete. Okay. So like yesterday, we'll start one by one. We'll start with Anirudh. First problem, tell me. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. Ashwin, you can also switch on your video. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is 1, 2, 3, 4. B is 2, 4, 6, 8. And C is 3, 4, 5, 6. Find A complement.
5, 6, 7, 8, 9. Sir.
5, 6, 7, 8, 9. No?
Yes, sir.
I'm not writing it here. A complement is, yeah, 5, 6, 7, 8, 9. Correct. B complement.
1, 3, 5, 7, 9.
Correct. All the odd numbers. What is A union C, the whole complement? First, you need to find A union C. What is A union C? A
3,
union C
4.
is, again, you're getting confused between union and intersection.
1, 2, 3,
Careful,
4,
careful.
5, 6.
1, 2, 3, 4,
5, 6.
5, 6. So what is A union C, the whole complement?
7, 8, 9.
Correct. So 7, 8, 9. A union B, the whole complement.
1, 2, 3, 4, 6,
So-
8.
So you told A union B. So 1, 2, 3, 4, 6, 8. So what is A union B, the whole complement?
5, 7, 9.
Okay. See, since you're doing it for the first time, I did it like this. But what you can do otherwise is, just now we saw one property, A union C, the whole complement. A union C, the whole complement will be A complement intersection C complement. So we wrote A complement, B complement already, right? If at all you write C complement also, then it will be easy for you to do that also. That part I'm leaving it to you. You guys can verify it. But I hope you understood what I'm trying to say, right?
Yes, sir.
So when you use this De Morgan's law, you should exactly get the same answer as 7, 8, 9. You get a wrong answer, then you went something. You did some mistake. Clear with that? Yes. So A union B, the whole complement, according to the De Morgan's law, it should be A complement, intersection, B complement. So you already wrote A complement, right? What is A complement? 5, 6, 7, 8, 9. What is B complement? 1, 3, 1, 3, 5, 7, 9. What is A complement? Intersection B complement. It will be 5, 7, 9. Odd numbers, no? So it will be the same. I hope you are able to understand what I'm saying. You can write and see. You can write and see, you will understand it better. So I'm just trying to validate with the property. A complements complement.
A.
1, 2, 3, 4. So what is B minus C? What is there in B but not in C?
2, 8.
No, B 2, 8 is there. 2 is there, no? B and B and C. Sorry. B and C, what is there? 2 and 8 are missing.
2 and 8 are there in B, but not in C.
Yeah, 2 and 8 are there in B, but not in C. So what is B minus C, the whole complement?
4, 6, 3, 5.
That's it. You understood why it is 4, 6, 3, 5?
Yes, sir.
Yes. Balaji,
Yes, sir.
second one.
So,
So A, B, C, D, F, G, H.
complement of set A is D, E, F, G, H.
Okay. I'm not writing it. D, F, G, H, correct.
Complement of set B is A, B, C. Yeah, only A, B, C. And H.
A, B, C, H. Correct.
Complement of set C is B, D.
One minute. I just want to give this hint. Just to validate whether you're right or wrong. No, just count the number of elements. Here you have 8 elements. In B, you have 4 elements. So when you told for the first time, right, you missed the H. So you told only 3 elements. So how many elements should be there in B complement?
4 elements.
How did you get? Because it is 8 minus 4. You should have 4 elements. If at all you miss, right, you can validate it like that.
Oh.
Okay, you can use that logic. Now what about C? C, you have 4 elements. So you C complement will also have 4 elements.
4 elements.
What are they?
They are B, D, F, B, D, F, H.
That's it. What about D?
Yeah, D complement will also have 4 elements. Hence, the elements are A, B, C. No, not A. Sorry. B,
A.
C,
B.
C, D,
E.
B, C, D, E. Yeah.
Correct. Yeah, correct. Ananya? Yeah.
First one's complement is all.
So X is an even natural number.
It will be odd natural numbers.
Yes, it will be odd natural number. For second one,
Even natural numbers.
even natural. Third one, X is a positive multiple of 3.
It's not a multiple of 3.
X is a prime number.
Composite numbers.
Yes. So X is a natural number divisible by 3 and 5.
All natural numbers that are not divisible by
Not divisible by 3 and 5. X is a perfect square. Obviously, X will not be a
perfect square.
perfect square.
It's not a perfect cube. X is not equal to 3.
X is not equal to 3. So 3 alone should be removed from the natural number set. Correct.
X is not equal to 2.
Is everyone able to understand why X is not equal to 3? See, X plus 5 is 8. So when you solve it, X will be coming out to be 3. So complement of it should contain all those natural numbers except the number 3. Correct. Similarly, continue. 2x plus 5 is equal to 9. So X will be equal to
4.
4 or 2?
2. Natural numbers except 2.
The natural numbers except 2. X is greater than or equal to 7.
Numbers except 1, 2, 3, 4, 5, 6.
Yeah, complement will basically be 1, 2, 3, 4, 5, 6. That's it. So should 7 be included or not? No, because here you have equal to. Correct. X belongs to natural number and 2x plus 1 is greater than 10. So 2x plus 1 2x plus 1 is greater than 10. X will be greater than 9 by 2. So according to this set, X should be a natural number and it should be a number greater than 9 by 2. So 9 by 2 is how much? 4.5. So what is the next natural number out of 4.5? 5. So basically this set, listen everyone, for the 11th question, right, the set will start with which number? It will start with 5. So what should the complement have? It should have all those natural numbers which are less than 5. So it will have only 1, 2, 3 and 4. Clear? So that is how it works. Fourth one. Universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, Ashwin, tell me this. 1, 2, 3, 4. Universal set is 1 to 9. A is 2, 4, 6, 8. B is 2, 3, 5, 7. Verify. So here your job is only to verify the De Morgan's law. Okay. So they are asking us to verify A union B, the whole complement, is equal to A complement intersection B complement. Even before you write the complement, tell me what is A union B?
A union B.
2. Tell me, 2.
Sir?
Tell me what is A union B?
2, 3, 4, 5, 6, 7, 8.
Correct. So what is going to be the complement of it?
1 and 9.
1 and
9.
9. Sorry. What is A complement?
A complement.
See,
1.
universal set has 9 elements. A has 4 elements. So A complement should contain 5 elements. So what are the 5 elements? What are the 5 elements? 1, 3,
1, 3, 5, 7, 9.
you have 5. Yeah. What is B complement?
B complement.
1.
1, 4.
Mm-hmm.
1, 4, 6,
Hmm.
8.
So what is
Nine.
A complement intersection B complement?
What, sir?
What is A complement intersection B complement? What is the intersection of these two sets? What is common in both?
1 and 9. Sir.
So is that not what they asked us to verify?
Yes, sir. It is equal.
A union B, the whole complement is A complement intersection B complement.
B complement.
So they're equal? Correct. So do the next one also. What is A intersection B, the whole complement? For that, what is A intersection B in the first place? What is A intersection beta?
Yes, sir.
What is A intersection B? What is common in A and B?
2 and only 2, sir.
It's only 2. So what is A intersection B, the whole complement? So what is there in the universal set but not there in A intersection? You will write 1, 3, 4, 5, 6, 7. Sorry. 1, 3, 4, 5, 6, 7, 8, 9. Means you will write everything from the universal set except 2.
Okay, sir.
Ipa sollu. What is, you already wrote A complement. You already wrote B complement. Tell me, what is A complement union B complement? Ashwin, only you are supposed to answer.
A complement.
Tell me the numbers. You need not do it mine. Just look at the numbers. What is there in A and A complement and B complement? 1. Union.
1 and 9.
You're doing intersection. A complement union B complement. 1, 3,
1, 3, 5, 7, 9.
4. 1,
3.
3, 4, 5. You have 6, you have 7, you have 8, you have 9. So if you observe, A intersection B, the whole complement, is the same as A complement union
B complement.
So they both are same. That's what they asked us to verify. Is they are the same? Okay.
Okay.
Next. See, for the fifth one, I want you all to work individually. Draw the Venn diagram and show it on the screen. See, even if it is wrong, it is fine. Don't look at any solutions. If it is beside you, you try on your own.
Sir, how do you draw Venn diagram for complement, sir? Do you shade the other part?
First, draw the Venn diagram for union. See, whatever you always look at the original set, right? So what I would suggest is initially first draw the universal set. Put the rectangle. Draw it. Put the rectangle.
Yes, sir.
Okay. So once you put the rectangle, what did they ask? They asked A union B the whole complement. Correct. We'll go step by step. Let's not overthink. Let's go step by step. Then I'll tell you how to directly draw it. 1 minute. Just give me a minute. So you have the universal set. You have set A, set B. So for set A union B, which part will you take? You will take everything within the first circle and the second circle. Correct?
Yes.
Anirudh, am I clear?
Yes, sir.
So what is A union B? The whole complement. Then is it not supposed to be this part?
Yes, sir.
That's it.
So how do you represent the other part? Just put arrow inside.
No need. Just write it as A union B, the whole You shaded it, no? In textbook, what they are doing is they are coloring it like this. It will take time for us to sit and do the smooth coloring. No, we'll just use the shades. Understood, Ada?
Yes, sir.
So what will be the answer for the second one? If you ask me, right, I'll just think of De Morgan's law.
Yes, sir. A union
A
B
union
whole
B, the whole complement is the same as A intersection
B intersection.
A complement intersection B complement.
complement.
So the diagram for both is same. Balaji, 1 minute. I need to zoom and see. Can you show me one by one? First one is correct. Second one, Kata? They both are same. Correct. Next. Correct. But you know, see for the second one, why didn't you shade the portion of B? Because the second and the third and the fourth.
Yeah, sir. I left that portion by mistake.
Third and fourth are same.
Yes.
Now you understood, no?
Yeah, yes.
Perfect. Ananya, are you clear, ma? Yeah. Okay. So this is the answer for A complement intersection B complement. Now I'll draw for the third one. Observe. So for the third one, if I take this as A, this as B, which is going to be the intersection? This portion, the convex part. The convex part, right? So this whole portion, except the intersection of A and B, is what is going to be the complement. Makes sense?
Yes, sir.
Right. So sixth one. Let U be the set of all triangles in a plane if A is a set of all triangles with at least one angle different from 60 degrees. What is A complement? Let U be the set of all triangles in a plane. A is a set of all triangles with at least one angle less than 60 degrees. Then what is A complement?
Equilateral triangle.
So it can be equilateral triangle or obtuse angle triangles, or it can be a right angle triangle. So it will go something like this, but we don't know, no? Like, read the question carefully. If this A is a set of all triangles with at least one angle different from 60 degree. Oh, sorry, different. I thought it's less than. With at least one angle different from 60 degree.
So A complement is only
A complement is
triangle.
every angle should be 60. It should be an equilateral triangle. Correct. So seventh one. Fill in the blanks to make each of the following a true statement. A union A complement.
Sir, union.
Yeah, union nala, what will be the answer? What will A
You,
union
you.
You.
You, sir.
universal set? Null set intersection A.
Yeah.
The complement of null set and intersection of A. What is the answer?
A.
Yes, sir.
Correct. So A intersection A complement.
Null set.
Correct. What is the complement of universal set intersection A?
Null set.
A complement.
It's a null set because universal set's complement will be a null set. What is the intersection of null set and A? There'll be nothing common, no? It's a null set. Am I clear with this? Right? So officially it's over as per the syllabus of 23-24. This chapter is over, but I'll be explaining some basics which is needed for probability chapter, right? So they are called as the practical problems on union and intersection of two sets. So now you are familiar with Venn diagram. So you have the universal set, you have A, you have set B. Then if this is called as A minus B, this is called as B minus A, and this is called as A intersection B. Have this in your mind because this is what we are going to use when you are going to frame the equations. I'll not call it as a formula. We're going to just use the logic and frame the equation. Suppose I have two sets A and B, which are finite sets. Right? They have finite number of elements. Then, if at all the A intersection B part is a null set, then how is a Venn diagram supposed to look like? This is one set and this is another set. Right? So, A has, let's say, number of elements in A is n of A. Number of elements in B is n of B. Then, if I do the A union B part, then how many number of elements will that A union B have?
N of A plus N of B.
N of A plus N of B, because they are disjoint sets. Suppose, had they existed like this, had they existed in this way, if this is A and this is B, you have A intersection B. Then what will be the number of elements in A union B? It will be the number of elements in A plus the number of elements in B. But when you write it like n of A plus n of B, you are writing the number of elements in the A intersection B twice. So what are we supposed to do? We need to remove it once. I hope you are able to understand. See, whenever you have these kind of problems, no. See, for example, here also, we took the union somewhere, no? I don't know where we wrote. But generally, whenever you write union, what do? We write the element only once. If the same element is present in both the sets, we write it only once. That is why you write it as number of elements in set A plus number of elements in set B minus you remove the number of elements in A intersection B once. Am I clear with that?
Yes, sir.
Okay. Now, the next question is, what if I have three sets? If A, B, C are finite sets, then the number of elements in A union B union C is going to be the number of elements in A plus the number of elements in B plus the number of elements in C minus the number of elements in A intersection B minus the number of elements in B intersection C minus the number of elements in A intersection C. But by doing this, you have removed the number of elements in A intersection B intersection C completely. So if this was not there, if this was not there, the meaning of it is you subtracted 3 intersections, number of elements in A intersection B, B intersection C, and C intersection A, right? You removed the number of elements from A intersection B intersection C completely. So you need to add it back. Meaning, how the diagram will look like is A, B, C. You removed the elements from here completely. So you are adding it back. Am I clear with that point? So that is all you need to know. So these are the 3 things which we need to know. Let's see some examples so that it's not a very big thing. You need to convert the given statements into mathematical expressions. It's a very simple topic. Okay, you're already good with the basics. Just look at it. Example 23. If I take X and Y to be 2 sets such that X union Y has 50 elements, meaning the number of elements in X union Y is 50. The number of elements in X is how much? 28. And the number of elements in Y is 32. Then how many elements does X intersection Y consider?
10.
Let's see. So number of elements in X union Y. See, now we don't know whether they are disjoint or joint sets. We'll apply the formula. So n of X union Y is n of X, number of elements in X, plus the number of elements in Y, minus the number of elements in X intersection Y. Just substitute the numbers. 50 is equal to 28 plus 32 minus n of X intersection Y. Bring it this side, take it to the other side. 28 plus 32 is 60. 60 minus 50 is going to give you 10. So number of elements in X intersection Y is 10. Am I clear with this?
Yes.
So it's simple, no? So this is how you will have. So I want you guys to try this problem. So just read the statement, convert it to mathematical form, then solve it. In a school, there are 20 teachers who teach mathematics or physics. It is or. Or means what are you supposed to use? Union or intersection?
Union.
Union. So number of teachers who teach math or physics is how much? 20. Of these, 12 teach mathematics. So what will you write? N of M is equal to 12. And 4 teach physics and mathematics. So N of M intersection P is
4.
How many teach physics alone? You can do it, no? One unknown, one equation, solve it.
Is it 12?
So, number of teachers who teach physics is 12. Clear with that?
Yes.
So if you're clear with that, do the next one. In a class of 35 students, 24 like to play cricket. So N of, for cricket, you can use the first letter. N of C is 24. And 16 like to play football. N of F is 16. Also, each student likes to play at least one of the 2 games. What is the meaning of it?
Yes.
N of
C intersection.
Intersection, it should have been and. It should have been and. No? Each student likes to play at least one of the 2 games.
Either this or
This
that.
one or that one. That is the meaning of it. So n of C,
Union.
n of C union F is how much?
40.
How is it 40?
45.
Also, each student likes to play at least one of the two games. Each
35,
student means how
35.
many are there?
35. Sir.
35. N of C union F is 35. Then how many students like to play cricket and in an intersection? N of C intersection F is how much?
Sir, could you show the whole question, sir?
That's the whole question. Huh?
Yeah, because the screen was hiding this.
Is it 5?
Cerulean. How much is it? 5. Huh? No, it's 5. Shall I proceed? So I hope everyone got 5, no? Right. Do the 26th one. No? So there was a survey of 400 students in a school. 100 were listed as taking apple juice. So apple juice, you can use A. N of A is 100 and 150 as orange juice. N of O is 150 and 75 were listed as taking both apple as well as orange juice. So N of A,
Union B.
they
G. Union O.
were listed as taking apple. Both were listed as
Okay,
taking
okay, sorry, sir.
It is and.
A intersection. O.
N of A intersection O is 75. Find how many students were taking neither apple juice nor orange juice.
Sir, can you show the formula for the example 25?
This same formula. This one.
Okay.
So neither of apple juice or orange juice means complement of A intersection
It
O.
is complement. They told neither.
Yeah, complement of A intersection.
It is a negation. It's a negative statement. No, it's negation. Number of students who are not taking apple juice or neither, no, apple juice and O dash.
$225.
225. Right? So we'll do one last problem and then wind up. Okay. 27th. Just literally convert the statement into mathematical form. There are 200 individuals which. So by the way, is everyone clear with 26 or anyone has a doubt? Everyone is clear?
Yes, sir.
Okay. So look at the 27th one. There are 200 individuals with skin disorder 120 have been exposed to chemical C1, 50 to chemical C2, and 30 to both chemical C1 and C2. Find the number of individuals. So first take down the data. No? There are a total of 200 individuals with some disorder. Number N of C1 is 120, N of C2 is 50, N of C1
Intersection.
Intersection.
N of C1 intersection C2 is 30. Find the number of individuals exposed to chemical 1 but not chemical 2.
N of C1 minus N of C2. No, C1 minus C2.
That's not how you take, no. You need not think of this thing, this part. You should not directly apply the formula like that. You should only convert that statement into union or operation. So it is basically means N of C1 and you're saying the second person has not got experience. Because both are happening simultaneously. I'm only concerned about the list where the person is affected because of chemical 1. At the same time, he is not affected by chemical 2 because there is a scenario where there are 30 people who are affected by both C1 and C2 put together. So in my statistical analysis, I'm trying to find out those numbers who are affected only by C1. That is the meaning. Are you able to understand what I'm saying?
Yeah, sir.
Yes. So the other way of writing C1 intersection C2 dash is number of elements in A minus B. That is C1 minus C2. I hope you are able to understand the solution.
Yes, sir, got it.
Got it? So what about the second part? Chemical C2 but not C1. N of B minus A, which is going to be N of B minus N of A intersection. Okay, what about C1 or C2? N of C1 union C2 or, so that's going to be 140. Am I clear with this? Right. So the remaining problems alone, you can try it out. Right. So with this, we are done, right? Miscellaneous part also, I'm leaving it to you. I want you to work as an assignment part and then come up with doubts. So whichever is unclear, that part alone I'll help you. Am I clear with this?
Yes, sir.
So next class, I'll be starting a very, very, very important chapter, which is relations and functions. And the following week on Saturday, what is the date? What is the following Saturday? 28th, May 6th. Right? May 6th, you will be having a test in this chapter. Okay. As per the previous board pattern, you will have MCQs, you will have assertion reason based question, case study based question, and subjective questions. So make sure you practice on. Okay.
Yes, sir.
So you all have this number, the student support number 6369210899. So if you have any doubt, right, you can reach out on this number. Doubt in the sense related to any concepts or something, we can reach out on this number, which is the student support number. Okay, you can make a note of this. Okay. Sorry. Okay. So keep practicing and work on the assignment as well. I'll see you all.
Yes.
Okay. Next week also we'll have it in the morning only. But
Okay.
it'll be in person there. Okay.
Yes.
Okay, guys. I'll see you.
Thank you, sir.
Thank you, sir.